Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Gülser. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.
Hello everyone, welcome to our conference, third international conference on water problems in Mediterranean countries, and later on, sixth international conference on natural resources and sustainable environmental management. Today in Cyprus time, in the morning, we have successfully completed our opening ceremony, and later on, the keynote speeches as well. Right now, we will start our conference. We have 3 sessions. Right now in room 2, we have 3 sessions, and in each session, there will be 6 presenters. Each presenter will have 15 minutes of time allocation. So please try to be careful about your time allocation. And at first, Dr. Sameh Ahmet Kantush will present, then Shifa Doğan will present, then Aliyu Ibrahim Polymerik. Later on, Awala Saleh Mubarak will have 2 different presentations. And finally, Ismaila Abubakar Boboy will have his presentation, and first session will end. Later on, we will have 15 minutes of break, and then we will start session 2, and after 15 minutes of break, then we will start our session 3. Right now, Mr. Sameh Ahmet Kantush will present, and so let's listen to Sameh Ahmet Kantush's presentation. We had some technical issues right now. Dr. Aliyu Ibrahim Polymeri, are you here?
Hello, what did you say?
Dr. Aliyu Ibrahim Polymeri, if you are ready, you can present now. Are you ready for your presentation?
Okay, I am ready.
Okay, doctor. You can present. Yes, I think we can see your presentation.
Hello, good day. My name is Ali Ibrahim. I'll be making presentation on the dairy wastewater treatment resource recovery using electrochemical based techniques. So we're going to be looking at what is dairy wastewater, what are the sources of dairy wastewater, composition and characteristics of wastewater, what electrochemical methods can be employed in treating dairy wastewater, what resources can be recovered from this wastewater, and what are the energy consumptions of these various methods. Now, first of all, what is dairy wastewater? These are waters that are generated from dairy-related processes from their industry. Whenever we engage in processing of material, for example, milk, into dairy products, waste are generated. These wastes contain different materials ranging from carbohydrates, proteins, fats, sugars, etc. Usually, these untreated or poorly treated water have effect on the environment. They could cause water degradation. Treatment of this water has been most oftenly traditional methods have been employed for treatment of water, that is using biological processes. Of recent, there have been growing interest in using electrochemical-based methods and hybrids for treatment of water. Now, what is the promise of this electrochemical-based and hybrid technology for treatment of wastewater? That is, they are able to overcome limitations of traditional biological methods. These traditional biological methods have issues of high sludge, they are very slow, and usually they bring about high cost. So electrochemical-based methods tend to offer more to promote the resource recovery from this method. It is also cost-effective. That is, the price you spend in it is relatively cheaper. It's also environmental because usually they bring about lesser amount of sludge. Most common processes in electrochemical-based method include electrocoagulation, in which we produce coagulant in situ using current, and also electrooxidation, in which we produce radicals that degrade these organic components. What are the sources of dairy wastewater? As I have said, they are the major source of this wastewater include dairy industries. These industries, this waste comes from heating and cooling processes, equipment cleaning, milk, product spillage, whey, and different things. Whatever use generally, the major source of this dairy wastewater is from the industry, and a lot of processes do happen in there. The wastewater composition varies depending on the product we are looking at. We have different dairy products ranging from cheese, pasteurized milk, butter, ice cream, dairy products. All of them, they have different level of composition that you get in them. Also, in addition to this, dairy wastewater could also contain clean agents, because whenever you carry out these things, you clean your cleaning plant, I mean the processing plant. So you also see some of these components in the dairy wastewater. On average, it is speculated that about 2.5 to 10 liters of wastewater is generated per 1 liter of milk that is produced. Now, what do you have in this dairy wastewater? As I've said, dairy wastewater is highly heterogeneous and it varies. It varies, the composition of this dairy wastewater varies from the source and the location you're looking at. So the source in terms of what type of water brings about this wastewater, where are you collecting it from, also affects the composition of this wastewater. Now, a lot of indicators we have been used that are used to determine how polluted the wastewater is depends of we use the COD, the chemical oxygen demand, and the biochemical oxygen demand to grade how polluted or what level of treatment has been achieved using a process to treat dairy towards water. Now, most often, other resources, other things that I've also looked at in the dairy wastewater include nitrogenous waste, including nitrogen, total nitrogen, nitrate, ammonium, phosphorus composition, also include phosphorus and total phosphorus. All these have also been analyzed in dairy wastewater. We also have physical parameters in wastewater include total dissolved solids, TDS, total solid, total suspended solids. All these parameters have been analyzed in dairy wastewater. We also have solid contaminant. We have volatile solid materials, volatile suspended solid material, suspended solid. All these are components that are found in dairy wastewater. Now, this is like a view of different works that have been done on dairy wastewater, and they have reported a quite range of parameters from their wastewater, including total phosphorus. And we can see that one research gives a value of up to about 500 milligram per liter, and we have a low value of about, where the guidelines for this is about 0.224 milligram per liter. We have COD, we have a value of high value of about 68,000 milligrams per liter. Then BOD, we have about 40,000 milligram per liter. All these values, different resources, different materials, different methods of treatment gives different. By the way, these values are the initial value before treatment. So these are the values that have been reported before the treatment. So you can see, depending on the method of the processing in the lab, I mean in the industry, depends on it. So it varies as high values and low values have been reported different, and we have a lot of components here that have been determined in dairy wastewater, as they have mentioned above. Now, what is this electrochemical treatment method? What do they do? The principle is based on using bring about electro degradation of anode. If you're talking about electrocoagulation, but in other methods like autooxidation, we use current to create what we call uh, a radical, which can further go to break down these organic compounds. Now, what are these electrochemical based methods? They are basically to three aspects. It's able to change your pollutant from physical change to another properties. So you could change your material entirely. Then we have the separation method, in which it's able to separate your pollutant from your matrix. Then we have a combined method in which it utilizes both conversion and separation method. Under the conversion method, you can see we have the electrochemical destruction, in which it destroys the pollutant entirely. We have electro-oxidation, in which the material is being oxidized. We have electron reduction, in which the pollutant is reduced. The oxidation state of the pollutant is reduced to a more less toxic material, less toxic state. Then we have the separation method. We have the electrofiltration, and these are other methods. I won't go in detail discussing this in that. So we have the combined method, including electrocoagulation, electrocatalysis, and these are other methods for this. Now, what advantage? We We have the factors that determine that controls the success of this treatment include what electrode type are you using, what is the distance of the electrodes between one another, what kind of arrangement are you adopting. The pH of the wastewater also determines the success of the treatment. How long are you treating your material? What's the temperature? All these factors affect the performance you get after the treatment. Now, what are the advantages of this method? They are energy efficient because they are able to give you energy. You can recover, you can treat a quite wide range of pollutants using this method. They are selective. You can design this material, this method, different. What are the resources? You can also we can recover valuable items using this method. They are simple and they can easily simple instrumentation. They also reduce the incidence of use of chemical, that is, they're environmentally compatible. That is, you don't have quite a range of materials used chemically that will affect, that will, that will impact the environment. So these are some work that have been carried out using different methods. These are work carried out. You can see they have used different materials now. And in this, the first experiment is they have used electrocoagulation, and they have reported they were able to remove 68% COD, 54% total solid, total nitrogen, 90%. These are the materials that they were able to remove. Now, you have other method also. This is able to treat, here they use aluminum. They were able to treat, they removed the turbidity. About 99.5% was removed after treatment. They were about 63.8% was removed. Another research here from, you can see these materials, this analysis, you have quite a number of different locations. Now you can see the last column, the last row gives the water from that was analyzed. This is the only paper that's reporting the treatment of dairy wastewater in Cyprus. And this is what they have used uh, electrocoagulation to treat wastewater from goat cheese whey, and they achieve about 40.5 COD removal, 38% total solid, and 23.9 phosphate. This research was carried out in 2023, so it's quite recent. That means there's still a lot of job to be carried out because we didn't find any data that has been reported for North Cyprus. Now, this is another comparing the performance of uh, electrocoagulation with electrooxidation. These are single processes. Now you can see we have the total, the COD that's been for this process, 28.9%. They have used a steel electrode. This is electrooxidation. But in this one, they have used it.
Dr. Aliyu Ibrahim, I think you have some connection issue. It was perfectly all right. We were listening to you, but for the last 5 seconds, it froze. Can you hear me? Are you there? You can also use the private chat. Okay, I think we are having a connection issue with Dr. Aliyu Ibrahim Polymeric. If he is available within the next minutes, I think he will he will be able to present, he will be able to continue his presentation. Right now, Dr. Shifa Doğan has a presentation, and let her present. So this is Dr. Shifa Doğan's presentation.
Hello everyone, I'm going to present comparative study of phantom and phantom-like reaction for the removal of AB113 from waters. My presentation contains
I think we have a problem with the voice. We will try to take it from the beginning. Sorry for Dr. Shifa Doğan for this.
Hello everyone, I am going to present comparative study of phenton and phenton-like reaction for the removal of AB113 from waters. My presentation contains introduction, materials, methods, results and conclusion. Reuse of water is important nowadays, especially for sustainable water management. However, the industrial wastewaters have high organic and inorganic loads, which are not easy to treat and deal with, such as the COD ranges from 2 to 13 grams oxygens per liter, as well as BOD and high and various pH conditions. So advanced oxidation processes are regarded to be the best option to deal with such tough wastewaters, high polluted wastewaters. And these processes are based on generation of radicals, and which have a high oxidation potential to break down the chemical bonds of those pollutants. And in this study, we have worked with phenton and phenton-like processes, which are best processes to deal with such high-loaded wastewaters. And the model compound was a textile dye, AB113. A phenton reaction based on generation of hydroxyl radical, as you can see from the reaction pathway. Hydrogen peroxide oxidize especially iron oxidizes hydrogen peroxide, and hydrogen peroxide turns into hydroxyl radicals, and iron is oxidized. In phenton-like reaction, which we use persulfate here, iron oxidizes and persulfate turns into sulfate radicals. So as in summary, in this study, we are going to compare the efficiency of hydroxyl radical and sulfate radicals to remove the model pollutant. And in this study, 500 milligrams per liter dye concentration was used, and the pH was adjusted to 3 before all the experiments, because these phenton reactions are best work in acidic conditions. And the molar ratios were selected as following: and di-iron hydrogen peroxide or di-iron persulfate molar ratios were 10-1-5, 10-5-5, 10-10-5, and these are the mostly studied ratios in the literature, and we chose to start with them. And the absorbance removal were recorded by UV visible spectrophotometer at 534 nanometers. In the results, we have observed that under low molar ratios, the phenton reactions gave better results, as you may see, and 42 and 45 absorbance removal were recorded under 10-1-5 and 10-5-5 molar ratios with phenton. On the other hand, phenton-like reaction resulted with lower absorbance removal, which was 13% and 38% respectively. In contrast, when the dose has increased to 10-10-5, the phenton and phenton-like reaction became comparable, and the similar removal percentage after 60-minute treatment was observed, which was 69%. And the degradation curves follow the first order kinetics, and it enables us to do some the observed removal rate constants enable us to compare the performances of the two reactions. And here we can see that Fenton reaction is much faster than the Fenton-like reaction, which was found 5 times faster. The observed reaction rate constant was 0.01 per minute for Fenton reaction, and on the other hand, for Fenton-like reaction, it was 0.002. And for the higher dose, as the removal percentage became similar, the removal rate also became similar. We can see this in the observed reaction rate constants, which were found close to each other, 0.15 and 0.13 per minute for Fenton and Fenton-like reaction, and respectively. In summary, for the conclusion of this research, hydroxyl radicals generated by the Fenton's reaction cause better absorbance removal and faster removal for the lower doses we have tested in the scope of this study. And when the molar ratio has increased to 10-5, the hydroxyl radicals and sulfate radicals performance to remove the AB113 and was comparable, and also the reaction rates were comparable too. Thank you very much for listening.
Thank you, Dr. Shifadoan, for your valuable insights. Now, our next presentation will be from Dr. Awala Salah Mubarak, and later on, Dr. Awala Saleh Mubarak will have another presentation. So we can start listening from Dr. Awala Saleh Mubarak.
Good afternoon all. My name is Awal Saleh Mubarak, and I will be presenting the effect of hybrid meteorological and environmental data for the prediction of chemical oxygen demand in wastewater treatment plants using explainable AI models. So today we will discuss about the effect of hybrid data for the modeling of wastewater treatment plant, which is located in Nicosia, Cyprus. So in this presentation today, we'll have the introduction of artificial intelligence, dataset and data preprocessing, model training results and discussion, and also conclusion. So wastewater treatment plant, as we all know, is always affected by many factors such as the climate, so the social, economic, political, environmental, and industrial factors. So these factors tend to affect the wastewater treatment plant. So, and also the main aim is to discharge a quality effluent, and in this effluent we need to look at the chemical oxygen demand, the biochemical oxygen demand, total nitrogen, so on and so forth. So it is very important to discharge a water that will be good for human consumption if possible, and also be that can be used for agriculture and other things. So the inflow and the outflow of the wastewater treatment plant can be affected by the meteorological patterns and the climate change over time. So traditionally, assumptions and rough estimation, also with a statistical method of linear regression, were adopted in the prediction of these outputs in the wastewater treatment plants. So the aim of the study is to predict the chemical oxygen demand in the new Nicosia wastewater treatment plant by achieving the following objectives. One, we're need to have a data selection, and also we need to process the data in such a way that it will give a good performance or give good features to the model when training. So we need to also choose the machine learning models that we want to use in the prediction of the COD. And also we will explain how the models make decisions using Sharp Explainer. So artificial intelligence is like mimicking human intelligence, kind of using statistics, algorithms, and all. So under artificial intelligence, we have machine learning and deep learning, and also there is a new study area which is the explainable AI, which gives human trust on how the models make decisions and which parameters are contributed a lot in the prediction or the decision making of that particular model. So the new Nicosia wastewater treatment plant is by communal wastewater treatment plant. Sorry. It's a bicommunal wastewater treatment plant. So the project horizon is up to 2025 and is expected to take care of 270,000 people. And it will be discharging 10 million cubic meter of clean water that can be utilized for agricultural purpose. So the data set that we are going to use, one is from the wastewater treatment plant, which is we level it at C1, and also the temperature from the data from NASA, which is the meteorological data. And this data will be split into 75% for training, and the remaining 25% will be used for validation. So the data input and output will be normalized into a range of 0 and 1. So the models that we chose to use in this study are the ensemble models, which are the gradient boosting, the categorical boosting, and the random forest. These models are based on the decision tree and random forest, so they are good ensemble models. So one, in the methodology, will have the data pre-processing, which is the normalization to make the values in to the range of zeros and ones. Then the training using the Nicosia wastewater treatment plant data, which is we level at C1. The training using the meteorological data, which we level at C2. And then the training using the hybrid data, which is C1 and C2. Then the model explanation will use the Shapley additive explanations, which is Shapley or Sharp. So after training the standalone model based on the performance criteria, the MSE, RMSE, MAE, and R square, for the model trained using the wastewater treatment plant data, we found out that the cat boost perform better in terms of when it comes to the validation of the model, which is the R square, and it has a very good fit with low mean square error or the low values of error. So when it comes to the meteorological data, the performance of the model was not good. So, but at least the random forest tend to perform a little bit in terms of the validation, though the training is good. And for the hybrid data, it turns out that the cat boost perform better with a better fit of 0.74, which is like 74% correct predictions when it comes to the validation data, the data that the model have not seen during the training. So for the explanation, we have two plots for the Sharp explainer. One is the summary plot, which is on the top. It shows the distribution of the contribution the input parameters made. This is for the hybrid data. And also we have the first plot, which shows how the variables tend to influence the decision making of the model. So we have the low ones in blue and then the higher ones in red. So this is all about the study. I hope that you enjoyed the presentation. Thank you so much. And also, sorry for the conclusion, we know that the wastewater treatment plant is a complex system. So in this study, we predicted the COD of the wastewater treatment plant using the meteorological data and the wastewater treatment plant data. And also, we find the best performing models when it comes to this modeling or the prediction of the COD. And also, we show how the models make decision using the shelf explainer. Thank you so much.
Thank you, Awala Saleh Mubarak. Right now, we can listen to your second presentation.
Hello. Welcome to the third International Conference of Water Problems in the Mediterranean Countries 2023. My name is Awal Salam Barak. I'm here to present the estimating biomedical oxygen demand using hybrid metro environmental data at the new Nicosia wastewater treatment plant. So here we'll have the introduction, feature, intelligence, data set, and data pre-processing, models training, results, and discussion, also conclusion. So as we all know that earlier that the wastewater treatment plant is a very complex system that is affected by many factors such as environmental, industrial factors, and the climatic factors. So the effluent or the water discharge from the wastewater treatment plant is very important to be treated before it is being discharged so that it will not harm people or will not affect the agricultural farming sector after being discharged. So the quality of these effluent materials such as the chemical oxygen demand, the biochemical oxygen demand and total nitrogen in the effluent is very important. So in this study, we'll try to use artificial intelligence or machine learning models, unlike in the previous time when traditional assumptions or rough estimations being used or classical models such as linear regression were adopted previously. So the aim of the study is to predict the biochemical oxygen demand in the new Nicosia wastewater treatment plant. So in this, we are going to achieve this aim by having good selection of the parameters or the variables from the data that we are going to employ, and also the selection of the machine learning models, and also to improve the performance of this model by applying an ensemble technique. So we all know that artificial intelligence is all about mimicking the human intelligence. So we are going to employ these models to see how the models will take in the data, make predictions of this particular um, biochemical oxygen demand. So the new Nicosia wastewater treatment plant located in Cyprus is one of the largest in the world, and it uses membrane bioreactor, which is also a good technology when it comes to the wastewater treatment plant. So the wastewater treatment plant is expected to provide the island with the clean water and also the water that will be used for agricultural purposes. So in this study, we are going to use two data sets. One, which is the data from the wastewater treatment plant and also the meteorological data from NASA. So we'll have different input variables such as the total nitrogen, phosphorus, pH, the conductivity uh, as the inputs, and also the effluent, which will be the biochemical oxygen demand or the VOD. So for the NASA data set, we have the relative humidity, the temperatures, and the maximum temperature, which are on daily readings. And also we'll separate the data into training and testing, which will use 75% for training, while the remaining validation will be 25%. The validation set will not be used for training, it will only be used for the testing. And also we'll try to normalize the data in such a way that we'll keep the data in the range of 0 and 1. So the models that we are going to employ today is the multilinear regression, which is a statistical method of predicting the outcome of one variables based on the values of multiple other variables. And then the least square support vector regressor, which is a regression technique that modifies the standard support vector machines approach to solve regression problems more efficiently. And also a Winston winner, a model for dynamic system combining linear dynamics with non-linear inputs and or outputs transformation. So for the ensemble, we use the feed-forward backpropagation neural network. So this neural network, it has the forward and the backward error propagation in order to minimize the error of the particular network or ANN. So in this, we have the data preprocessing, whereby we'll normalize the data to the range of zeros and one for both the input and the target. And also we'll train using the wastewater treatment plant data. Also we use the meteorological data as well to train the standalone models. And also we'll make a hybrid use of the wastewater treatment plant data and the meteorological data in order to improve the performance of the prediction of the BOD. So in this, after we train the data, we tend to find out for the meteorological data, we have three models here. And it turns out that the MLR performed very well, which is surprising in terms of validation, which is the left-hand side with 0.44% fit. But the Hamilton winner for the meteorological data, it performs better, which has better fit of 80% in terms of the prediction of the model, correct predictions. And also the Hamilton winner for the hybrid data, it performs better compared to the other models, though it is lower than the meteorological data prediction, which is surprising. For the ensemble technique, we use the outputs of the three models and we use back or fed them into the feedforward neural network to predict the BOD, and the performance tends to outperform all the other models with a better fit in terms of validation with 0.84%, 0.84, which is 84%. So this shows that the ensemble technique can help in improving the performance of the models in the wastewater treatment plants. So in this, we show that we can use different data sets in terms of predicting the biochemical oxygen demand. And this shows that all these parameters that we use can affect the levels of the effluent or the BOD that we are trying to predict. And also we compared the performance of the models in the prediction of the biological oxygen demand, and also the effect of the ensemble model, whereby it improves the overall performance of the model. This is the end of my presentation. Thank you so much.
Thank you very much, Dr. Awal Saleh Mubarak, for your second presentation. I can see that you also have your third presentation in our session 2. The session 1 is now over. Thank you for your attendance. We will continue with our session 2. Thank you very much for joining our conference.
Hayat hızla Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarını yakın. Hepimizi ileriye